Hello, Eastview Scholars, and welcome to this edition of Sharp Shorts on water and nutrient cycling. This is a big picture tutorial. We have looked at carbon, we've looked at water, we've looked at our chemistry review, and we've looked at some macromolecules, proteins, carbohydrates, etc. And now let's jump a little later and do a big picture of what does this mean overall for ecosystems, etc., so that we see the tie-in as to why we're looking at this level of organization at the chemical level before we move on to cells and organisms. Certainly we know that water is the biological medium. We've talked about carbon as the framework, and we've looked at the most important thing, our CHNOPS, as those chemicals that all living organisms need. Now, all of these things are things that are in, especially the nutrients, the chemicals are in a finite reserve. They need to be recycled in our world and in our local ecosystems and stuff to provide the materials that we need to be living organisms. So the overall thought here as we go through this is in the back of your mind to continue to think and to look in your chapter of bioremediation and stuff as to what is our effect, and if we throw these cycles out of balance, how does that affect the ecosystem and all the living things in it. Okay, so here's one we've already looked at. Here is carbon. The largest source of carbon is in the atmosphere and carbon dioxide, and then photosynthetic organisms then utilize that and make it into carbon forms that can be used by consumers and stuff. And of course a lot of this stuff happens as organic materials decompose and stuff. They go back in to the atmosphere, and we if you think about it, you know, the amount of photosynthesis that is removing carbon dioxide from the atmosphere should, in theory, be the same as the cellular respiration and the decomposition. What has happened with industrialization and the burning of fossil fuels is that we are putting more carbon dioxide in the atmosphere than photosynthetic organisms can take care of. What does that lead to? Well, a couple of things, and really it leads to one thing that everybody's concerned about and talks about, but they often put the two together. And they talk about global warming and the greenhouse effect, and they make them synonymous, and they are not. The greenhouse effect is simply in our atmosphere with carbon dioxide and the other greenhouse gases, the nitrogen oxides and water vapor and stuff like that, that as the solar radiation from the sun heats the earth, if we didn't have these greenhouse gases and stuff, then it would all radiate out of our atmosphere, and on average our temperature would remain unlivable for the organisms. What these do is then reflect the heat back and keep us at a stable temperature. So greenhouse effect in itself, in allowing those gases in the atmosphere to re-radiate the heat, is not a bad thing. What has happened, as you can see here too, and here is a look of the red line is average temperature over years, and this is in Hawaii, and here is the carbon dioxide levels. Now what you can see is a pretty steady increase of carbon dioxide levels in the atmosphere. What you can also see is you have a very fluctuating temperature curve. Okay. So, and some folks argue then that is carbon dioxide really the source of global warming. Well, what you can see though is a trend, an increase in the temperature, and it doesn't take much temperature to do things. But that's the example of things that I want you to look at, is that if we upset these cycles overall, how does that affect our environment and our Earth? And to point out that greenhouse effect in itself is not a bad thing, but our continued unbalance of the carbon cycle is leading to global warming and needs to be addressed. Okay. Here's the water cycle. We don't need to spend much time on this. This is an earth science thing. 97% of our water is contained in the ocean, and its availability influences it is the biological medium of life, so it does influence dramatically the organisms that live in those ecosystems. So you can see the cycle comes from just transpiration and evaporation of water into the atmosphere, which comes down as precipitation. Now, one of the things to consider as we do this is continually recycling, and water is the best solvent that we have. And so as we do overload these other nutrients, as a human species, if we are overloading through industrialization and just our what was our development over time, then those are things that also can dissolve into water vapor and lead to such things as acid rain, etc. So again, things to keep in mind of what happens in the imbalance. We don't necessarily throw out of balance the water cycle itself, but we can affect things that with global warming and stuff that allow that to be effective. Okay. The nitrogen cycle. Nitrogen is the largest gas in our atmosphere, the most prevalent gas in our atmosphere, and it's a key component, as you know, to amino acids and peptide bonding and making proteins and nucleic acids, often a limiting reactant in plant nutrients. And we are at a point too with industrialization where our activities are outpacing nature's ability to fix nitrogen fixation through bacteria and other organisms. Ammonium and nitrate are the nitrogen compounds that living organisms can use, and so the abundant amount of nitrogen in our atmosphere needs to be fixed by organisms into compounds, as you can see in the smaller outbreak, that plants can use and stuff, and then can be used by consumers. Again, with industrialization, we're kicking nitrogen oxides and other reactive gases in there, which is not allowing the fixation and the denitrification to bring nitrogen gas back into the atmosphere out of balance. Okay. And using them in fertilizers and everything else is adding that addition, as will be with phosphorus. And then with the, depending on how you look at it, you can look at it as deforestation, as we planted more and more croplands and stuff close to water areas, and changed the runoff factor, then that did change the amount of nitrates and stuff in the water supply, and left more greenhouse gases, and also leads to, as we'll go to phosphorus here, a problem with eutrophication, where we are changing the ecosystem, and if it goes long enough, eutrophication can get rid of the lakes and lead to more swampy and land-based areas. Here's phosphorus. Phosphorus is the one cycle that doesn't have a whole lot to do with the air. There's not much phosphorus gas. There's a little from wind blowing and weathering of the rocks, but mainly our phosphorus cycle is in the rocks and the plants in the form of phosphates. Used to be believed that it was very localized in ecosystems. Of course, its importance is in nucleic acids, phospholipids, which are part of the cell membrane, the main component, and ATP, your energy molecule. But more and more evidence is coming out that while phosphorus, because it's not a big atmospheric recycler and not very prevalent in atmospheric gases, is that it was very localized to the ecosystem. But as we're finding with runoff and eutrophication and getting into rivers and streams and everything else, it is much more than a localized thing in the ecosystem. So, but anyhow, you can see, and you can use your book to understand how these cycles actually work. And again, their main function is to continue to provide, as organisms live and die and decompose and everything else, to bring those, to continually recycle those nutrients that living organisms need. And if there's an imbalance, and we don't have to blame it all on humans, but we are the ones that brought in the age of industrialization, how does that affect the ecosystems? How do we, and just as we move and build houses and take up land and everything else, and drive our cars, how does that adjust for things as we build big factory farms and stuff? What are we doing, and how can we remediate to minimize our impact in changing that cycle? So anyhow, things to think about. There's good information in your book, but I'm going to tell you right now to scholar up, Eastview.